I want to continue our discussion of R by now going into branching structures, aka conditional statements, looping structures, and other essential things I need to know prior to going into assignment number 0 that deals with the Monte Carlo simulations. First, let's cover branching / conditional statements. These are just statements that allow distinct pieces of code to be executed depending on some logical condition. This is your classic if else, or if else structure. So, as an example, let's say I had my num is 10. And I say if my num is greater than 5, and we open up this curly brace and this closing curly brace, we can write some statements to execute in here, and they will only execute if this condition is satisfied. So we can use a function called print to show something to the screen. Satisfied condition is true. Otherwise, we can say else, let's do, and R is complaining about it, so I have to put it here. Else will print unsatisfied condition is false. And we should be able to reasonably predict what the answer should be here. And I'll show you a keyboard shortcut, Control Enter, to run a line. So global environment changes. So my number 10, go back to grid view, it's a numeric. And now have a look at this. I get the output satisfied that the condition is true. And notice that that doesn't end up in the environment anywhere. It just displays it to the screen via print, and then it leaves the screen, essentially. It doesn't change anything with the environment. And notice that this block here didn't run because this condition was met. Now, if I change this to less than 5 and ran the same thing again, say, now I have not satisfied the condition is false, so we took a different branch. We could do more complicated stuff than this, of course, but this is just a demonstration. So, let's do something slightly more useful. In this case, let's say we have age, and it's 14. And then we have is student, and let's say that's true. Then what we can do is say this: if age is less than 18 and or is student, and this is short for saying is student equal to true, and print eligible for discount, else print not eligible for discount. And then now, if we run these, we get the output eligible for a discount, as you would expect. So this is a little bit more complicated, but just some indication of how we might reasonably use these. And because R is vectorized, you could think that we can maybe apply these on vectors as well, and that's absolutely correct. We can, and I want to explore that in the following example, but let me pause briefly. The way we can do it for a vector is by using the if-else function. If-else will take in some element of a vector, some condition to check, and then an argument if it's true, and an argument if it's false. And we can chain this to another call to if-else to continue to check for an alternative condition. So let me show you what I mean by that. Let's say I had a vector called ages, and this is people from ages 14 to, let's say from ages 2 to 20. So I'll run that again. We got an integer vector 2, 3, 4, 5 all the way up to 20. Now, what I want to do is I want to assign 3 groups. So, and let me just print ages just so we can see what it looks like. Yep. So what I want to do is I want to assign 3 groups. If you're between 2 and, let's say, 9, or 2 and 5, you're a toddler. If you're between 5 and 10, you're a child. If you're between 10 and 15 or 16, you're a teenager. How can I reasonably do this? So, let's try simple here. Let's just try the first bit, toddler. So, the way we would write this is if else, and the first thing is a test. So I say ages less than, greater than equal to 2, and ages less than equal to 5. If that is true, if that holds, we'll say toddler. Otherwise, we say not toddler. Now let's run this first, just to investigate the output. So we see the first 4 are toddler, and the rest are not toddler. And the reason for that is, if we look at the first few values here, they are 2, 3, 4, 5, which satisfy these conditions. So therefore, this true expression evaluates. The rest don't satisfy it, so this results. We can chain this, of course, to handle more of this. So we do if else, age is greater than or equal to 2, and ages are less than or equal to 5. Say that's toddler. But if that's not the case, then we can say if else, age is greater or equal to 5, and ages less than or equal to 10. We could say that that should be child. Or, if that's not the case, then we do another if else. And in this case, we don't even have to do, we can just say ages greater than 10, in which case it will be a teenager. And there we are. And then now if you run this, we have to provide a default false here, so none. And run this again. And here we have our new output. Toddler, toddler, toddler for the first few, then child for the next few, and then teenager for the rest. And so that's how we can use this. Now, one thing you might have noticed is this is running onto, this is a very long line. So how can we split this? That's what I want to cover next. So I'm just going to pause briefly. What we can do is very simple. We can just split it on multiple lines like this, and it becomes more readable. And we can still run it and get the exact same output that we'd expect as we had before. Okay, so now let's talk, now that we've talked about branching structures, I want to get into looping structures briefly. So, this is a new section, looping structures. And the 2 looping structures I want to cover are for and while loops. This is something that we've been exposed to in Python, so the idea should be familiar, but I'm going to start in a very simple way and just keep everything kind of brief. So, overall, both of these structures are used to repeat some block of code many times. A for loop will iterate or go over step by step, element by element, over a sequence or some vector a certain amount of times and execute some block of code a certain amount of times. And a block of code is literally anything that's defined between 2 of these curly braces. So it has the for loop has the basic structure like shown. For some value in some sequence do something. This is where code goes. So, usually it's customary to have value be the lowercase letter I to stand for iteration, but it could be literally anything you want, almost. So, let me just do a very simple example first. Let's say I did this. Remember that we can use this shorthand to create a vector. So what I can do is this. For I in 1 to 5, print I. And so now, if we run this, we get 1, 2, 3, 4, 5. And we see that I is added to our environment. So we see that this prints out the value of I on the current iteration. Then when this loop body has ran once, the value of I is incremented or increased by 1 to 2, and then the loop body is ran again. Just to make this very clear, I'm going to do this. I plus 1. And again, what I'm going to do, just to show that this works, I'll change this to J. And if we have a look, now we get 2, 3, 4, 5, and 6. So again, to explain what's happening here, is we initialize J to start at 1 here. Because it's starting for every element in this sequence. So the first element is 1, and we're printing 1 plus 1, which is 2. Then we end the body, and we go to the next iteration. J gets incremented to become the next value in the sequence, which is 2. 2 plus 1 is 3, which we get as the output. And that concludes that loop, or that code block. Then we go to the next iteration. This becomes the next element in the sequence, which is 3. 3 plus 1 gives us 4. And you can see the similar sort of logic repeating. This is incredibly useful if we know how many times we want to repeat something. While loops, on the other hand, which I'm going to cover below, while loop, these are more useful when you don't know in advance how many times you want to repeat a particular code block. While loops will continue executing as long as a provided specified condition is true. So, they have the signature while condition, and then do stuff in this, and as long in this block, and as long as condition is true, this will repeat forever. So if we don't do something to make condition false, eventually this loop will never end. Now, a common thing to do is that we'll specify a value outside of the loop that will be our termination condition. So let me say k is equal to 0, and then I'll say this: while k is greater than 0, I'm going to print k, and then I'm going to say k is k minus 1. Now, what do you think will happen here? This condition is not even true, so it won't even run. But what if I change k to 10? 10 is greater than 0, so this holds. We'll print 10, and then this will decrease k to 1 lower than 10. But that's still true, so it should repeat. Let's investigate that, though. Control Enter, and then this. So now we have a 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 countdown. And we can see now k in our environment is set to 0. 0 is not greater than 0, so that's why our loop has terminated and execution goes back to outside of the loop. So that's how we could use while loops. But one thing I will show you is we can also have a while loop that continues kind of forever, essentially, and we can actually break it ourselves. And that's what I want to explore in the next bit of code here. Let me just pause very quickly. So let's create a very simple loop here. Let's say we have a variable called counter. and we set that initially to be 1. Then I'm going to create a loop here where I'm going to check this condition. While counter is less than or equal to 10, I want to do something. But what I'm going to do is I'm going to increment counter. But what I want to do is once counter equals a specific value, let's say 6, I want to stop iterating over the loop. So just to review, I've initialized this counter variable, this name, to be 1. Associated, I binded the name with the value using the assignment operator. I'm beginning a while loop, and I'm checking this condition, this logical. As long as it holds, this body will repeat forever. But I want to use a condition, a branching statement, a conditional statement to break out early. So what I'm going to do is this. If counter double equals, because I'm doing a comparison, 6, break. So this will end the loop when counter equals 6. And actually what it will do is actually end the loop right there. It won't continue. Just to make the case clear, I'm going to print out the value of counter. And just to make sure we don't have an infinite loop, I'm going to say counter is counter plus 1. So that in the first iteration it'll be 1, this will be true, it'll print out 1, and then it'll increase it down up to 2, then 2 is still less than or equal to 10, so it'll print 2, increment it to 3, and so on, until we get to 6, and then this statement should run. So let's look at that. See how I only get 1, 2, 3, 4, and 5? I don't get 6, I don't get 7, I don't get 8, I don't get 9, I don't get 10. So you see that when this condition is true and break is encountered, it immediately halts the execution of this entire looping structure, and it moves execution to immediately after it. And just to make that point very, very apparently clear, I'll say print this should only appear after while has been broken. So we'll run this, and there we are. So this is something that you might find handy, also something just to keep in mind. The final thing I want to mention in this video is some other useful stuff, for lack of a better word. And these are things that you're going to need in assignment 0 that are covered earlier in the course, that are essential elements that allow us to do Monte Carlo. And these relate to randomness. So the first function I want to cover is sample and sampling in general. So sampling in our context at least, refers to taking some amount of values out of a vector randomly. And we can choose to do it with or without replacement. Without replacement is the default, and that means, what it means is simply like this. If I had a vector 3, 1, 2, 5, and I sampled 2 values without replacement, let's say 1 and 2, then they're removed, and the only 2 options available to me now are 3 and 5. If instead I sample with replacement and I take out 2 values, I could take out 1 and 2, but they're still available. I can take out another 2 and I might get 2 or 5, or another random 2 and get 3 and 2, so on. We usually want to sample with replacement, and that's an argument we could specify in the sample function. So first, let me define a vector. Let's call it, you know what, names. Why not? So this is a vector of names. So let's say Alex, Lynn, Morteza, and Chris. Okay. So we'll run that. We have our name. We have our 4 names there. And now let's say I want to get 2 of the names at random with replacement. So in order to do that with the sample function, it's quite easy. We just do this. Sample, we put the vector we want to sample from, which is names. we want to put the size of the sample, which in this case is 2, and then we set the replace argument to be true. And have a look at what this returns. We get Lynn and Chris the first time, but I run it again, I get Alex and Lynn, and I run it again, I get Lynn and Morteza. So you can see that it's randomly sampling from these 4. And there's only 4, so you're going to see a lot of reoccurring values. But you'll see that we are getting randomly 2 elements every single time. We could actually, if we want, make this bigger and repeat this, but that's how we would pull 2 values in. And actually, we can simplify this to just be t instead of the whole word true, and it still should work. And there we are. So that's how we would sample in this particular case. We could change size to get a bigger sample or a smaller sample. We could change this to get replacement. We could do something like simulating a dice roll if we want, now that we know loops and how to sample. So let me show you that particular application. So we know that a fair die can land on any one of 6 sides. So let's try to sample, I don't know, 20 dice rolls, or 10 dice rolls. So we can do this. For I in 1 to 10, because we know we want to do it a specific number of times, in this case 10, go sample, and we can nest a vector in here, so another function, so concatenate. So concatenate, or even better, 1 to 6, size equals 1, replace equals true. And this will get a sample from the vector 1, 2, 3, 4, 5, and 6, 1 value with replacement, which is a dice roll, and it'll do it 10 times. And so let's see what this outputs. Now, of course, it didn't really output anything because I didn't tell it to. So let's print out, let's assign this to a value. Say this is roll. And let's print roll. So running this again, we should get output this time. So Control Enter. And here are our rolls. 1, 6, 1, 6, 1, 1, 5, 4, 5, 6. And we should expect, if we ran it again, to get different outputs. So let's run it again. 4, 4, 5, 3, 3, 3, 3, 3, 2. I have a very weighted die by the look of it, but this is how we could do something like this to randomly get values and return them. And we can even see that roll has a value here. So that's how we could do sampling. The next thing that I want to talk about is random number generation. So randomly generating numbers in a range. So this is something that we have to know how to do. And there are a lot of functions in R to do this. But the one I want to particularly talk about is RUNIF, which is short for random uniform. This lets us generate random numbers from a uniform distribution. And so by default, this function will only take in a single argument, and it'll produce that many random numbers between 0 and 1. But we can also specify our minimum and maximum boundaries to get that many numbers between the minimum and max. So let me show you the simple case here. The function is runIf, or R uniform. So let's try running R uniform 5. See, the defaults are 0 for minimum, 1 for maximum. So if we run this, we get 5 numeric decimal values between 0 and 1 in this case. We could run it again, and we should expect to get completely different numbers, and we do. And we can repeat this as much as we want. We can also do something like this. 5, minimum is 10, maximum is 50. This will give us 5 random numbers between 10 and 50. And there we are. And we can run it again and get another 5 random numbers between 10 and 50. And these numbers can be literally anything we want. We can change this to, 50 numbers between 10 and 50. And if we ran that again, we would get this kind of output. And you can see how this could be useful, for example, if we want to randomly generate numbers and then fill them in. Now, the question maybe on your mind is, okay, so we're returning these decimals. Is there a way to get the whole number portion? Meaning, can we round this and get, for example, from here 15, or from here 47, or from here 13, or from here 37, and so on? And there definitely is a way to do this, and I want to explore this, and I'll do that right after a brief break. The easiest way to do this is by wrapping this in a function called round. Round is a function that will take in some input and the number of digits to round it to. So, as an example, let's keep it simple to begin with. So the round function, let's try rounding pi to 2 decimal places. So round pi digits equal 2. And we run that, we get 3.14. And just as a reminder of what pi equals by default, it's not 3.14 by default, it's 3.141593 ongoing. So you can see how this might be useful. We could, of course, wrap everything that we wrote here in round. So, just to show you that, we have round, run if, our uniform, 50, the minimum is 10, the maximum is 50, and outside here, digits is 0, round to a whole number. And then control enter. And now you see we get 50 random integers. And we can assign these. So we can say randoms. It's this. And then let's print out randoms. So run it again. And then print out randoms. And there we are. There's our vector of random numbers. 50 of them. And we can even sort them. We can do whatever we want with them. We could say, for example, practicing some indexing randoms, where randoms is greater than 20. And there are some values that match that condition. So this is how we can do some more advanced, slightly more advanced things in R, and these are some concepts that you need to be familiar with coming into assignment number 0. And so I'll leave you some time to practice with that. In particular, I would practice with sampling as well as using random uniform here, because these are things that we're going to have to do often. Another thing is just to make sure that you know how to do indexing, because that's something we'll also have to do relatively frequently.